In the inky blackness of the vast empty space, billions of miles from home, NASA's Voyager 2 marked a milestone of exploration, becoming just the second spacecraft to ever enter interstellar space in November 2018. And now, we've seen what is beyond the threshold, and we have more insight into some of the universe's biggest mysteries. These are the strangest discoveries made by Voyager 2. Purpose. On November 5, 2018, Voyager 2 left the solar system as it crossed the Heliopause, the boundary that marks the end of our little bubble and the beginning of interstellar space. This happened approximately 119 astronomical units from the Sun. As it exited the bubble, it was able to analyze the makeup of solar winds, the composition and behavior of plasma particles, the interaction of cosmic rays, the structure and direction of magnetic fields, and other traits that define the edges of the solar system. But these findings don't come close to other discoveries the spacecraft has made. These are the 5 strangest discoveries made by Voyager 2. The Heliopause bubble is leaking. The departure of Voyager 2 from the bubble came with some unexpected news. According to the data, the bubble appeared to be leaking. The Voyager 1 spacecraft was first to notice any interstellar radiation leaking through the bubble into our solar system, and the Voyager 2 only solidified these findings. New discoveries show that the 2 spots where our Voyagers exited aren't the only spots that are vulnerable in the bubble. There are a lot more. Temperatures in the Heliopause reach up to 89,000 degrees Fahrenheit or 31,000 degrees Celsius, which is about double the temperature projected by our prior astronomical models. This indicates that the solar wind and cosmic rays out there clash more violently than we had anticipated. And while the Heliopause's heated, thick wall of plasma shields our solar system from a majority of hazardous rays traveling across space, its boundaries are not as consistent as one might expect. The Heliopause's edge isn't a flawless bubble because it includes porous holes that allow interstellar radiation to flow in. So, this sheath of hot, charged wind protecting our solar system might not be perfect, but it's the only thing standing between us and the wilderness of space. For that, perhaps we should be thankful. Increase in space density. As the Voyager craft ventured deeper into interstellar space, the density of space increased, defying our widespread belief that space is a vacuum. The findings of Voyager 2, which measured the density at a different position in interstellar space, mirrored the findings of Voyager 1, which calculated the density at a different location in interstellar space. The density of matter here is low, but it exists. The solar wind has an average proton and electron density of 3 to 10 particles per cubic centimeter in the solar system, but it decreases as you get further away from the Sun. When Voyager 1 crossed the boundary that lies between us and outer space, it detected a plasma density of 0.055 electrons per cubic centimeter by monitoring plasma oscillations at a distance of 122.6 astronomical units. As it gets further, it only makes sense that it should decrease, but as the craft went further, it reported an increase in density at 0.13 electrons per cubic centimeter. Voyager 2 in 2019 reported an even higher count than that. But what could be causing it? One theory is that material blown by the interstellar wind slows as it reaches the Heliopause, causing a sort of traffic jam. This has possibly been detected by the Outer Solar System probe New Horizons, which in 2018 picked up a faint ultraviolet glow resulting from a buildup of neutral hydrogen at the Heliopause. Another theory is that the interstellar magnetic field lines become stronger as they drape over the Heliopause, causing instability that depletes the plasma from the draping region. In fact, Voyager 2 did detect a stronger magnetic field than expected when it crossed the Heliopause. But can the Voyager crafts operate far enough and long enough to provide us with the data? The Sun's influence goes beyond the solar system. The Sun consistently spews out shock waves of plasma called coronal mass ejections or CMEs, which help shape the rest of the solar system. Where once we thought our Sun's impact ended at the Heliopause, it now turns out it goes beyond the very confines it created. The new Voyager 2 data, like the Voyager 1 data before it, shows how CMEs propagate past the heliopause and lower the amount of cosmic rays beyond the bubble. This is somewhat similar to what you might find out in the galaxy. Supernovae send shockwaves out into the galaxy as well, stirring the interstellar medium, albeit at a much more intense scale than CMEs. Most astronomers believe that even the formation of the solar system was triggered by an interstellar shockwave from a supernova. The cosmic rays have the potential to promote biological mutations in life on Earth. Could the Sun also have an influence on the evolution of living things on extraterrestrial worlds in this planetary system and elsewhere? Even decades after launch, the Voyager craft are breaking barriers, having flown past the giant planets in the late 1970s and 1980s. Voyagers 1 and 2 are now well beyond all their planetary targets, with Voyager 1 more than 5 times farther out than Neptune and Voyager 2 not far behind. No one knows how much longer the two spacecraft will survive. They have to stay warm, so that the fuel they need to keep their antennas pointed toward Earth doesn't freeze. Voyager's heat comes from plutonium, but as the radioactive element decays, it provides less and less power every year. If we can just make it to 2027, it would be 50 years of Voyagers in service. But if not, we can be thankful for the incredible amount of information they have given us about the universe.